Today's video will demonstrate how to determine the level of redundancy in a given object-oriented design. Hello, I'm James Helfrich. One of the great things about object-oriented design, especially with inheritance, is the ability to collect all the functionality common to many classes into a single centralized location. This reduces redundancy. The question is how to determine the level of redundancy of a given design. The redundancy metrics helps us with that, and this video will demonstrate both what the redundancy metrics is, as well as how to compute it. Inheritance redundancy is the extent in which common elements exist in an inheritance tree. If an attribute or operation exists in two related classes, then it should probably be moved into the base class. When the inheritance tree fails to do this, we have redundancy. So it turns out we have several levels of this redundancy. Distinct is what we're looking for. There are no duplicate attributes or operations. Obviously, this is the Holy Grail. Minor, any duplication exists in non-adjacent classes. In other words, there might be a redundant operation or a redundant attribute, but they're not sibling classes. They're far apart in the inheritance tree. Sometimes this is acceptable and even desirable because the amount of work required to remove the redundancy would be greater than the benefit received from it. Critical is when siblings have attributes or operations. This is bad. In almost every example here of critical redundancy, we should move that common operation up to the base class. And then redundant. Multiple instances of redundancy exist in the tree. Clearly, we don't want to have this. So let's take a look at an example. I have a list application that has a display, edit, add, and remove virtual function. We have my shopping list, my budget, my meal planner, to-do list. Observe that pretty much all of these guys have a list item in there. So the base class has no attributes. It really only provides the interface. Further investigation reveals that all the derived classes have the same attribute. Purpose for this inheritance hierarchy is to collect classes for the purpose of polymorphism, yes, but the classes share the same interfaces, which are very, very generic, but this appears to be only motivated behind design. There is no apparent attempt made to reduce or eliminate redundancy. So therefore, this is redundant. We can clearly do better. Here's another example, also the same list application. All three derived classes have the same method reset. And since all three copies presumably do the same thing, therefore we have critical redundancy. We want to avoid that. Okay, we're going to do a little bit better here. We have the list. We're going to have linear versus hierarchical, assignments, to do, grocery, and meal plan. The assignments and meal plan, they seem to have a shared attribute, but they're non-sibling, they're not adjacent. Now, because of this, we're going to have a level of redundancy, but it's not critical. It's going to be just minor. We could fix it by moving that data all the way up to the base class, to the list base class, but that means that to-do and grocery will have an attribute they don't use, which is less desirable. All right, now we have a shopping list, which can have many list items, a check item or a date item. And it's going to have every shopping item is categorized as a Christmas list or to-do list or so on. Now, there are no duplicate attributes in the inheritance tree, and all the unique member variables are list, categorized, date item, and a check item class. And this supports the assertion that it's distinct. All the code also is to manage categories are in the categorized base class. Similarly, all the data code is in the data item, and all the checkbox code is in the check item. This supports the assertion that this is a distinct level of redundancy. Now, designing out redundancy can be reduced with the DRY principle. Don't repeat yourself. It's useful to think of variance and invariance. A variant is an attribute or operation that is unique to a given class. You can say that there are variants are defining characteristics of the class. If a base class contains elements unique to a subset of classes, then move that uniqueness down in the inheritance tree. Invariants, on the other hand, are attributes or operations that are shared between classes. As common elements are found in classes, put commonalities in the base class and make the rest child classes. So every time you look at an attribute or operation, ask yourself, is this a variant or invariant? If it's an invariant, move it up the inheritance hierarchy. If it's a variant, move it down. This is example 33.1, .2, .3, and .4 in the redundancy chapter of the software design textbook.